Okay, this is the final section of the chapter, so I just want a real quick review of what we talked about last week. So last week we looked at angles that happen on the circle. So if the angle is on the circle, let's call this 100 degrees, then your angle measure is going to be 50. So it's half the arc equals the angle. And I should say the measure of the arc if we're being technical in the measure of the angle. The next one we did, let's try that again. Oops. Half the measure. Let's draw another circle here. There we go. The next one we did was we looked at two chords intersecting. So if we call this 50 and let's call that 70, then it's half the measure of arc plus the measure of arc equals the measure of the angle. So 70 plus 50 is 120. Cut that in half, so that angle would be 60 degrees. Okay, the week prior to that, we looked at what we called central angles. And that's where if this is 60 degrees, this is 60 degrees. So that, when it's a central angle, the measure of the arc equals the measure of the angle. Okay, what we're going to look at today is angles that fall outside of the circle. So we're going to look at two secants, two tangents, or a secant and a tangent, all of which the angle is located on the outside of the circle. So here's your three scenarios. So if I do some highlighting here, in each of these scenarios, you have two arcs that are formed by the two secants, or the two tangents, or the tangent and the secant. So there's the first arc that's formed, and then we have a smaller intercepted arc. So if you notice in all of these formulas, it's the measure of the bigger arc, and then we're going to subtract from it the measure of the smaller arc. And then you take half of it just like we did last week. So it's always half the arc measure equals the angle measure. Sometimes you add, sometimes you subtract, sometimes it's just half. So just keep that in mind when we take our test next week. Okay, so the first example. First thing I like to do is I like to highlight. So I have the arcs that are intercepted as this one here, and this one here. So we're going to look at, does that angle land in, on, or out? So angle is on the outside, so that tells me that it's a subtraction problem. So 170 minus 72, that's going to be 98. And I'm going to take half of that, and that equals 48 degrees. Hey, look, that changed a square into a circle. Okay, excuse me, 49 degrees. Should double check all the stuff with my calculator. So the angle measure there is 49 degrees. Okay, the second example is going to be a review of some of the things from the trig chapter, and then just going through and reviewing what we talked about at the beginning of this chapter. So it says you're flying an airplane about 5 miles above the ground. What's the measure of arc BD, the part of the Earth that you can see? They say Earth radius is about 4,000 miles. So they want us to calculate this arc here. Now, because they labeled AD as 4,000, and they labeled AC as 4,005, I'm going to redraw that triangle. That's a terrible triangle. So that's a right angle because of the tangent properties from earlier in this unit. So I know that this is 4,000. I know that this is 4,005. So I can find the measure of this angle here. And then I can use the properties of a central angle. Or I can find the measure of this angle here and use the properties from, I shouldn't put a single tick mark there because those aren't congruent. And then I can use the theorem from this chapter. I'm going to use the easier one, so I'm going to find that first angle measure. So if 4,000 is adjacent, 4,005 is hypotenuse. That tells me I need to use cosine. So cosine of the angle equals adjacent over hypotenuse. So anytime I'm trying to solve for an angle, I got to use inverse. So the measure of angle A, I'm going to grab my calculator here, is going to be cosine inverse 4,000 divided by 4,005. So that's going to give me approximately 2.863291. So a very small angle there. Now, because of things from first semester, we know that in this picture up here, so make sure you guys are looking back at the picture, the two triangles formed, this triangle, ADC, and this triangle, ABC, those would be congruent triangles because of the theorem hypotenuse leg. So if I found the measure of angle CAD, I can double that. So if I multiply that times 2, that's going to give me 5.726596. Now it doesn't tell us what to round to. So I'm just going to round to the nearest whole number. So that would be 6 degrees. So then the measure of arc BD would also be 6 degrees. And the reason for that is because that's a central angle, because they talked about the radius in the problem. So we know that we can just find that central angle, and we know that that arc measure is going to be the same arc measure. Now that is definitely not drawn to scale, if you guys look down here, because that 6 degree measure is definitely looking like it's a lot bigger in the picture. So never trust the pictures when you do this stuff. We're not going to try to throw like crazy curveballs at you, but just make sure you understand. Again, this is kind of a review. I don't know that there's anything specific on your test where you have to go through this process. We will do some additional things with lengths of those lines in the next chapter. But for this chapter, you just have to find the angle measures when you're doing it. And the arc measures, I guess I should say. Okay, so let's do a review real quick. So here I have 26 degrees is the angle measure. If I highlight, there's my arc measure. There's my other arc measure. And I know the angle measure. So I know that y minus 30, if I take half of that number, that's going to give me 26 for an answer. So if I double y minus 30 is going to be 52 degrees. I don't know why I just did that. That's kind of weird. Turn my shape changer off there. And then finish solving this one, I would add 30. So y has to be 82 degrees. So I want to double check that. 82 minus 30, that's 52. If I take half of that, that gives me 26 for my angle measure. So that did indeed work. Okay, last question here. DE is 4, so this is similar to the other one. DE is 4, they're telling us that this little piece in here is 2. So if I go through and I redraw that triangle, I know this is 4. I know this little chunk is 2. And I know that a radius is always the same length in a circle. So again, if I go through and do the same process, if I want to find this angle here, I know adjacent and I know hypotenuse. So if I do adjacent and hypotenuse, that's going to be cosine of angle equals 4 divided by 6. So to solve that, we cosine inverse. So I go to my calculator real quick. Cosine inverse of 4 divided by 6. I'm recording a video. Do you want to come say hi? You can say hi to the students. My wife says hi. She just asked what I was doing. It's weird when I'm sitting down in the basement talking to myself. Okay, back to the math. So cosine inverse of 4 divided by 6 is going to be 48.1896851. So then I can go through, again, like we did before, if we double that to get that central angle, so if I multiply that times 2, that's going to be 96.379370021. So if I round that to a whole number like we did on that previous problem, that's going to be 96 degrees is, let me draw on this arc measure that we just found, or excuse me, the angle measure. So we found this angle measure, which is a central angle, which means this arc measure is going to be the same measure. The question, though, wants us to find this one. So mathematically, I'm going to take 360 minus 96. So that's going to give me 264 degrees. Okay, so that is the final section. Again, when angles are located outside of the circle, you subtract the two angle measures and then divide by 2. If you're solving for an arc, you just have to do a little extra algebra. It's the arc minus the arc. Cut that number in half equals the angle measure. Okay, just like last week, homework assignment is already in your OneNote, so it should be there to do. Attendance is going to change again this week, so you guys are going to have the full week to do everything all the way through Sunday, also with attendance. So I'm going to change that and just say, as long as you guys have your stuff done by Sunday, like 8 o'clock, because then I go on and I check everything after that. If it hasn't been done already, I'll check periodically to go through and see who's doing it right away, but you won't get penalized this week. So things will close up on Sunday at 8 o'clock. So that'll go for the quiz that you take this week and so forth as well. So go to the homework, get that stuff done right away. Go take the quiz from last week. Again, you have 20 times to take that quiz. Get 100% on it, so that boosts your grades. And then next week we will take a test, and I'll give you guys some instructions on that, either probably in a Word document that I'll post on Schoology. All right, enjoy the rest of your week.